Okay, so in the last video we talked about this init graphics method and setting up our max x, max y, x center, y center, and this min max xy thing. And then you see right after that in the first line they use this min max xy and multiply it times this 0.95 float to get side. Now side seems kind of straightforward. That's probably going to be the side length of our triangle, right? That's because that's the name that he picked for side, that he picked for the variable. So it seems like it's going to be the side length. What is this 0.95f times min max xy? Well, let's take a look. What we saw before was that we could use this min max xy to make kind of a like an absolute boundary that we want our triangle to stay inside of. And maybe make that a little bit clearer why we need to do that. I'm going to flip over to the refactored version here for a second so that I can set the number of triangles to 1. I just want to draw just one triangle. And let me run this. And remember, when you have multiple files and you want to run a file, in order to run the program, you need to pick the one that has the file that has the little run button next to it. That's going to be your file, your class with the main method in it. So we need to run off of our triangles class. So I'm going to go over here to the triangles.java. And it even comes up here and says contains the main class. I'll right click on it, or maybe control click if you're on a Mac, and then say run file. And it just has the one triangle because I changed my triangle count to just be 1. But the reason I'm pulling this up is to just show you when we resize this window, we could resize it so that it's so that the height is bigger than the width, right? We still want the whole triangle to fit inside there, so we have to use so if we were just using the maximum of width and height, well, this height now is longer than we are wide. Our triangle would be sticking off the edges of the canvas, right? So we need to kind of maintain a square that we're staying inside of, so that our triangle stays on screen. Now, also, we had that multiple of 0.95. Well, look at if we made it. If we made our square be exactly to the edge, to the of the minimum. So right now, our width max x is going to be our minimum of max x and max y, right? We don't want these corners to be right at the edge there. We want them to be inside a little bit. So it makes sense to kind of, if we multiply that min max xy by 0.95, that's going to give us a little bit of edge in here. And we can, you can also, like, again, I said, there's lots of ways to play around with this code. You could play around with that number. What I did was I pulled it out and I said drawing to canvas ratio. I called it drawing to canvas ratio because it's kind of a ratio that we're using to fit our triangle inside the canvas. So if we made it like say 75, let's see what that looks like. All right, and I encourage you to play around with code like this. And now if we fit it, now see it's much smaller in relation to the, see we have more of a margin over here. Or if we made it like 50%, what would that look like? Okay, so now the triangle is much smaller in relation to the canvas. the canvas gets bigger, the triangle still gets bigger, but we have more of a margin. The ratio is smaller, so the ratio of triangle side length to the canvas, to the min-max XY of the canvas is smaller. Okay, so I'll just put this back. Okay, so that's what's going on for our side. Let me flip back a second to the book version. So that's what's going on to the side. Side half seems pretty straightforward. We're multiplying side by 0.5 to get the side half. We'll have to think for a minute why we need the side half. Well, look right here what's happening. We have this h equals the side half times the float of math dot square root of 3. So that's our h. So let's think about that. Now, if we look here, the green rectangle here is actually of height h. And if we think about it for a second here, we're making an equilateral triangle, right? We're drawing an equilateral triangle with vertices A, B, and C. And we'll look at the vertices in more detail in a second. But what we want is we want to have a triangle of height h and side length side, okay? And this distance from here to the center is side half, and this distance from here to here is side half. Well, if we were looking at just, one half here, this triangle right here, this should be familiar to most of you if you had should have been exposed to this. This is going to be, since a triangle has 180 degrees altogether, right? This equilateral triangle, the big equilateral triangle, is going to be 60, 60, 60, right? All three angles are the same, so it has to be 180 divided by 3. That's 60 in here, right? This is 90 degrees if right here, right? So this inner triangle is going to be 60 plus 90 is 150, so I need 30 more to get to 180. So this is a 30, 60, 90 triangle, right? So, and also, the length of this is half the length of that. So if we thought about it, this is having a length 1 and this has a length 2, then h is going to have a length square root of 3, right? So whatever this length is, if we multiply it by the square root of 3, we get the height. So that's what's going on here. We're saying side half is half the length of a side, right? And then h is that side half times the square root of 3. So that's where that comes from. Okay, so then in the next video we'll start talking about all these vertices.